Hey guys, this is Mr. Grice for Miss Carranza and Mr. Grice's Algebra 1 class. Today we are starting Chapter 2, Section 2.1, and these are the notes. Today we're going to be talking about sets of numbers and the number line. Our goal for you today is to be able to identify, compare, and graph different types of numbers. So if you look up, I've already got two definitions written down for you. Uh, you can go ahead and start copying those down. But what I'm going to start discussing are all the definitions that are below. So if you need those vocab written down right now, go ahead and pause the video. Otherwise, we are going to keep going. All right. So integers. Integers are the set of numbers in this little guy right here. So now, dot, 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 dot. What that means is it keeps going. Okay? Now, if you look at integers, we have positives and negatives. The key thing to integers is there are no fractions and no decimals. Okay? Rational numbers. A rational number is any number or any numbers that can be written as a fraction of integers. Okay? Now the key thing here, whoa, let's get that back. Fraction. So what that means is we can have, oh, not an example yet, I'm sorry. Things that can be written as a fraction are a repeating decimal or an ending decimal. And we'll give you two examples of that real quick. Now, if we have negative 2/3, okay, what that looks like is a negative 0.66666666, and this number keeps going on forever and ever and ever. Now, if you have a calculator, what that calculator does is when you divide 2 divided by 3, it rounds it, okay? But in reality, this number keeps going on forever and ever, okay? But since we can write it as a fraction, it's considered a rational number, okay? Our next is example 0.125, okay? That can be written as a fraction, okay? If you put it um, into your calculator, most of you guys have buttons that say fraction to decimal where you can plug it straight in, okay? When you do that, it comes to 1/8, okay? All right. Irrational numbers. These numbers cannot be written as a fraction of integers, okay? So what that means is non-repeating decimals and non-ending decimals. I'll give you two examples of those too. So a non-repeating decimal, when I think of this number, it's got no pattern, um, and it goes on forever and ever. And when I think of this, I get really, really hungry, and that is pi, okay? You can go on excuse me, you can go on Google and look up the digits of pi, and it goes on forever and ever and ever, and there's no pattern to it. Another example, negative 3.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You cannot write that as a fraction. Okay, so that's why that's called an irrational number. Okay? And our last definition, real numbers, and real numbers are the set of all rational and irrational numbers. Okay, keyword there, all. So to help you figure this out, we're going to make a little chart right here. At the top, we have real numbers because all numbers are real numbers. Real numbers can be two different things. They can either be a rational number or they can be an irrational number. Now, rational numbers can also be integers. Integers can also be whole numbers, and then whole numbers can also be considered natural numbers. Now, to practice these, the best thing to do is just get a list of numbers and try to figure out where they all go. So, here's our set of numbers. Let's start picking them out. So, integers. Integers can be those two, okay? Positives or negatives, but no fractions, no decimals. A natural number, on here it's only positive numbers, no fractions. In this one there are none. Whole numbers here, there's only one whole number, and that is the number 0. Rational numbers we talked about could be fractions. They can be decimals. They can be repeating decimals. And they can also be integers. Okay, so there are a lot of different rational numbers up there. Irrational numbers are non-repeating, non-ending decimals. There's only one up there. And the real numbers, all numbers are real numbers. So all numbers in these sets. Okay, let's do another example. It says, given the set of numbers, list all of the rational, irrational, and integers. All right, let's start working on this. So, first thing I'm going to pick out, I see rational numbers are my fractions. They're my ending decimals. So we got 4/9, 7.98, 5 1/3. They're also those guys. Okay. What we're left with are the irrational numbers. Square root of 5. Now, if you don't know what the square root of 5 is, I would suggest putting that into your calculator. Okay. This is a non-repeating. Okay. There's no pattern to this. Okay. And it cannot be written as a fraction. So that's why that's irrational, along with the number 2.35821 ... Okay. But which ones are the integers? Remember, those can be positive and negative numbers. No fractions, and we got -6 and 23. All right, let's flip it over to the next one. So graph the following numbers on a number line. Be sure to label each number in its original form. Okay? Oh, highlighter. There we go. So if we're going to create a number line, we need to know where what all of our numbers are. So here are some numbers that I'm not sure exactly. Oh, I know what that one is. 0.9 is easy. But we got to figure out what those numbers actually are. So 7/8 equals -2 1/2 equals 49/9 equals, and the square root of 11. And to figure out exactly what they equal, we're going to use our calculators and get the exact decimal. So 0.875. -2 1/2 should be -2.5. 49 divided by 9. 5.44 repeating. And the square root of 11. Square root of 11 is 3.31. So now that we know what those numbers are, we need to graph them on the number line. And to graph them, we need to write down what each one of those dashes mean. And now we can start graphing. So our first one, -4, I'm going to put a dot where it's at, and then I'm going to label that dot. Okay, 7/8 is 0.875, so it's almost to 1, but there's just a little room. And we're going to label it by its original number, okay? Original form. The next one is 3. -2 1/2, we said that was 2.5. 49/9 was 5.44 repeating. We have 0.9. And the square root of 11. There we go. We graphed them. Now it says use the number line above, insert a greater than or less than symbol to make the statement true. Now this says the farther to the right a number is, the greater it is. So let's look at 0.9 and 7.8. Well, there's 7.8, 0.9. Which one's farther to the right? Okay, so that means that 0.9 is the greater than. When we draw our little Pac-Man right here, the Pac-Man always eats the bigger number. Okay? And let's look at B. It says 3 and 5 and 4/9. 5 and 4/9 was also the 49/9. Okay? And which one is bigger? Which one's farther to the right? 3 or 49/9 or 5 and 4/9? The 5 is, make sure the Pac-Man's eating that. So this will read 3 is less than 5 and 4/9. Okay, let's go ahead and look at example number 4. Example number 4, I'm going to let you guys do all on your own. Please go ahead and pause the video right now. Hey guys, I said to pause it. All right, thank you. All right, hopefully these are the answers that you guys got. All of the numbers are written clearly on their number line so you can see and labeled in their original form. And on the bottom half, comparing the numbers. All right, if you guys have any questions, please come find Miss Carranza or myself. We would love to help you out. Thanks, guys.